Hello and welcome to this short tutorial on the AIM Review tool. AIM Review is a web application developed by researchers at King's College London. It uses artificial intelligence to accelerate the screening process in systematic reviews. The tool runs directly in your browser, so there's no need for complicated installations or setup. AIM Review follows a modular structure, where each step of the systematic review process is handled in a separate module. In this video, we'll be focusing on the machine learning prediction application. This is the module of the tool that allows users automatically predict the relevance of unscreened publications using nested and cross-validated supervised machine learning pipelines. If you haven't yet watched our previous tutorial on the labeling application, which is used to upload your literature and begin screening publications with the help of AI, we recommend starting there. You can find the link in the video description. If you already know how the labeling application works, to get started with the ML prediction application, follow the link to the AIM Review website provided on the screen or in the video description. This will take you to the AIM Review homepage. On the left panel, under Applications, you'll find a tab called ML Prediction. Click that to enter the module and begin. Supervised learning is a machine learning technique that uses labeled datasets to train algorithms to predict outcomes. In our case, supervised learning models are trained with a subset of manually labeled publications to predict the relevance of the rest of publications not screened by the user. Nested cross-validation is a methodology that allows us to train and optimize model parameters while obtaining a reliable assessment of the model performance in publications not used for model training or optimization. In nested cross-validation, a subset of screen titles and abstracts is used to train and optimize models to predict the relevance of publications. The data is split into two levels of cross-validation, an outer cross-validation for model evaluation and an inner cross-validation for hyperparameter tuning, ensuring an unbiased and robust performance estimate. By following this procedure, AIM Review is able to produce reliable predictions of the relevance and irrelevance of publications not manually screened by the user. In doing so, it helps semi-automatize the screening process, saving time and effort in conducting systematic reviews while maintaining transparency and methodological rigor. Now, let's bring this to life with an example. If you remember from our last video, we ran a literature search across PubMed and Web of Science and screened a random 20% of the publications. The goal was to identify publications that use machine learning to evaluate or develop diagnostic or prognostic models in mental health. What we're going to do now is take that 20%, those manually reviewed papers, and use them to train our model to predict the relevance of the remaining 80% of unscreened publications. This setup simulates a real-world systematic review scenario where your search yields hundreds or thousands of results, and you simply don't have the time or resources to screen them all. Instead, you label a subset, and let AIM Review guide you to the most promising remaining publications. To follow along with this tutorial, head over to the shared Google Drive folder linked in the video description. There, you'll find all the files you need. Download them to your computer before moving on. Alright, with that background in place, let's now take a look at how to load your data from the labeling application and configure the prediction pipeline inside AIM Review. We'll walk through the steps together. To start, head over to the Load Config tab. Make sure that the pre-selected file type is set as Labeling Output Spreadsheet. In the main window, click Choose Files and upload the file named labeling.xlsx. Once that's done, just hit Import. After importing, you'll see that the application has recognized 60 labeled entries, that's 20% of your dataset, along with 238 unlabeled entries. These will be the ones we'll be predicting. With the data successfully loaded, it's time to define the text vectorization settings and configure our nested cross-validated supervised learning pipeline. To do that, go to the ML Config tab. From here, we're going to select three vectorization methods, TFIDF, LSA of TFIDF, and sentence transformers, which use deep learning models via the transformers.js library. For the classifier, select logistic regression, and for the performance metric, choose Balanced Accuracy, or BAC. In the classifier config, make sure to set the class weight to balanced. This helps deal with class imbalance, which is common in systematic reviews. Next, open the CV config section. We'll leave the defaults here, 1 inner and outer permutation and 5 folds for both inner and outer cross-validation. Once that's done, go ahead and close all modal windows to return to the main interface. Now let's take a moment to break down what we've selected. We're using a combination of text vectorization strategies, TF-IDF and LSA of TF-IDF, introduced in the previous video, and a sentence transformer that transforms documents into 384-dimensional vectors. The default ensemble setting, model stacking, will automatically train individual base learners for each vector type, then use a metamodel to combine their predictions for a final result. And logistic regression with class balancing as our classifier, a fast and shallow learner. Our nested cross-validation setup is configured as 1 permutation and 5 folds for both inner and outer loops, which provides a robust and unbiased estimate of performance. Head to the documentation page for a detailed description of each configuration method. With everything configured, the next step is to vectorize the text. To do that, simply press the Vectorize button in the main window. One thing to note here is that vectorizing using the sentence transformer model will take noticeably longer than TF-IDF or LSA of TF-IDF. This is because it relies on a large artificial neural network structure, trained with a large number of documents. This is more computationally intensive than frequency-based methods such as TF-IDF, but also more powerful in capturing the contextual meanings of language. This might take a few minutes, so we will fast forward to the point when vectorization is complete. After this, you'll be given the option to save the vectors into CSV files. We recommend doing this. It allows you to reuse the vectorized data later without having to repeat the entire process. Just follow the prompt to download each CSV file to your local drive. Now that your documents have been vectorized, it's time to train the model. Click Train Model and Aim Review will begin the training process using the nested cross-validation setup we defined earlier. You'll see a progress window displaying all the details of the configuration, the vectorization methods, the model type, and the ensemble strategy. As training progresses, the app will generate a set of visualizations, including inner and outer cross-validation performance plots, ROC curves, and performance metrics for the held-out data. These insights give you a detailed understanding of how your models are performing, both during training and in validation. Because we uploaded unscreened publications earlier, Aim Review will now automatically generate predictions for their relevance using a default probability threshold of 0.5. Unscreened publications with a predicted probability above this threshold are labeled as relevant, and those below as irrelevant. You can adjust this threshold depending on your needs. For example, raising it to be more conservative, or lowering it if you prefer to capture more potential candidates as relevant publications. And it is this simple. If you want to extract these predictions, just click the Save Labels button. This will open a download window for an Excel spreadsheet containing both the predicted labels and the probability of relevance for each unscreened publication. In addition, you can press specific publications and see the title and abstract. Before wrapping up, we encourage you to experiment. Try swapping out the classifier, testing different vectorization methods, or tweaking the ensemble strategy, then rerun the vectorization or training to see how your performance metrics change. Just keep in mind that some vectorization methods and classifiers, especially deep learning models, may take longer to train and generate predictions. The good news is that Aim Review lets you run this module in parallel with the labeling application, so you can train and evaluate models while continuing to label your samples in the other module. And that brings us to the end of this short video tutorial on the ML prediction application. If you have any questions or encounter any bugs, please get in touch. We're always happy to help. We hope Aim Review enables you and your colleagues to save a substantial amount of time in your systematic reviews, without compromising quality or transparency. Be sure to check out our other videos covering the different modules of Aim Review, as well as our organized seminars, and don't forget to cite Aim Review in your publications. Goodbye and thank you for watching.